Welcome all of you to ANIMATHS. We shall be taking up the division method of square roots today, and we shall also be taking up few sums on the division method of square roots. Okay, so we shall be taking up few sums like what must be added to a number to make it a perfect square, which are based on the division method, or what must be subtracted from a number to make it a perfect square. And we might do few more problem sums on the division method of square roots in this video. Okay, so let us see how we started. Here we have the number 6561. Okay, and we need to find the square root of this, but this time not by prime factorization method but by the division method. Okay, so what do? This is how we start, and the very first thing in division method that we need to do is we have to make pairs of the numbers. Okay, so here we'll be pairing the numbers. Okay, and the pairing has to start from the right end. So if I have 78250, then the pairing should go like this, and this should be 1. We should never leave a number without a pair at the end. So pairing starts from the right and it goes like this, leaving the 1, if it is an odd number of digits, the last one to the left is left without pairing. Okay, so now here, very first thing, we should look at the first pair. This is the first pair, and we have to think which is the perfect square which fits into it. Now this is not difficult because it is within 100. So we know all the perfect squares within 100. Okay, so which is that perfect square which fits in this, and in that case it is an 8. So we write an 8 here and also an 8 here. Okay, we write an 8 here and we also write an 8 here, and we write 64. That is the perfect square. Then 1, we subtract. Okay, just like a normal division, we subtract and it's a 1. Bring this whole pair down, not 6 just. In normal division we would have brought down the 6, but here we'll bring down the 6 1. Now you have to listen very carefully. This 8, whatever is written here, gets doubled and gets written here with a blank here. Okay, don't push it to this end, we need space here because we are going to write 1 or 2 digits here. Now we need to write a digit here. It can be 1, 2, 3, 4, anything, but we have to see if we write 161, then we have to do 161 into 1, and that product we have to write here. If it is a 162, then it is 162 into 2, that is 324, we have to write here. Now we have to write one such number so that when it is multiplied, when here if we write whatever digit, with the same digit we are going to multiply here, and when we multiply we should get a number which is very very close to this, lesser than this or close to this, like we do in divisions. Okay, so here I think the best option is 1, because if we put 2, it's going to be 324, which is greater than this. So we need only 1 here, because into 1 that gives me a 161. Okay, you can do this calculation in rough. Now 161 will be written here. You can see on subtraction I am getting a 0. Here this 1 that you have written here gets copied here. Okay, so my square root of the number 6561 is an 81. Okay, so this is how we find the square root of a given number. Now this was a square root which did not have a remainder, but remember you will have square roots where sums where there will be remainders. So there's nothing to worry if this is just the beginning. So we have taken numbers, we have taken perfect squares, but after this if they give you this method is meant for numbers which are not perfect squares too. So after this, if they give you a number which is not having a remainder or which is having a remainder, it is perfectly okay. So okay, because when it has a remainder, then we start with decimal, means the square root goes into decimals. So as of now, this example we will not have any remainder. Okay, so let me take up another example of square roots, okay, which is 2116 again, 2116. Okay, this is the pairing. Okay, if it's even number of digits, there is no problem in pairing, but if it is odd number of digits, you have to be very careful, pair from the right side. Now I am looking for a number which is lesser than this, but then a perfect square. The perfect square which is just lesser than 21 is 16, because 5 square is a 25. So 4 here and a 4 here, and this is a 5 here. 516. Okay, then this 4 gets doubled and gets written here. Okay, this 4 gets doubled, gets written here. So this is 8, and this one is, there's a gap here. Okay, what do we put here? Okay, because I have doubled this 4, don't double this 4, there's a reason why I'm saying so. This is, you have to double this. Of course both are 4s, but the number here has to be doubled. Now what should I write here so that I can go very, very close to 516? That is 80, how much? If I take, this is 51. So if I take what? That can take me very close to 516. Tell me. So if I take a 5, okay, if I take a 5, 85 into 5, that is 25 to 425, that is less. Let's try with 86. 86 into 6, 36, 3, 48, 516. Okay, so how did I come to 5 or 6? Because I saw the 51 here. When I saw the 51 here, I thought I should work with, because 8 5s is 40, so somewhere with 5 or 6 I should work. So my digit here is 6. Okay, and we have multiplied it with 6 and got a 516 that I'm going to write here. This digit gets copied here. Okay, and so my answer is, square root of this is 46. And we should also take a quick look at this last digit. 46 into 46, last digit 6 into 6 will be a 6. So we have a 6 here. So this was the division method of doing square roots. Okay, so after this we shall be taking up few type of sums which are based on this division method. Okay, so let's see how it is. 4 9s. Okay, now what must be added to, as you can read in the question, to make this a perfect square? So the question itself is saying this is not a perfect square, but still we'll start with the division method. Okay, so here pairing again, and then this is what is the closest perfect square? That goes to 999. Yeah, I think 8 into 8 is a 64, 9 into 9 is an 81. If we do 10 into 10, it is 100. So why not 9 and 9 and then 81 and then 8. Okay, so I get 18 as the after subtraction, and then bring down the full 99. The entire pair has to come down. This has to be doubled, 18. Okay, there's a gap here. Now this has to be filled with one such digit so that I can reach very, very close to this. Now remember, this time I am definitely not going to get 1899 for sure. I am not going to get 1899 because it is not a perfect square. Okay, but then what will I get? I will get something close to this. So 18 and then what can take me very close to this. If I take a maybe if I take a 1, it won't work because I'm going to get a 181. Okay, let's try with a because I am seeing too many 9s here, so let me try with a 9, because one thing I can see for sure, 1899 is very close to 180 into 10. Okay, but then if we take 180 into 10, we are going to get this is we are not still expecting a double digit over here. Okay, of course we can write a double digit, but as of now we are trying with a single digit. Let me try with a 9, and if that fits in, 81, 8, this is 9 is a 72, and then 72 and 80. Okay, so that gives 1701. Okay, 8, 9, this is 1. So here this is 9. Okay, so 99 is my square root, but then as I said, it is not a perfect square. Now what to do? Okay, so if it is not a perfect square, how can we, this 99 is not my, this 9999 is not the square of 99. We have a remainder of 198. Okay, so we have to understand how this number can be made into a perfect square. Now how can this number be made into a perfect square? What must be subtracted from a number to make it a perfect square? Now one thing that is very obvious, that if this remainder was not extra in this value, that is, if we can subtract this remainder, then this will become a perfect square. So 9999 minus 198, okay, that is 1 and a 0 and a 8. Okay, so and 9. Okay, so 9801, that is the perfect square after subtracting this, right? Because this number failed to be a perfect square because of this remainder. So we are taking out this remainder and making it a perfect square. So what must be subtracted from this number in order to make it a perfect square? Your answer has to be 198. Okay, don't give the answer as 9801. It is the perfect square that we have made after subtracting it. But what must be subtracted is 198. Okay, so we'll take up another sum in which we shall be doing what must be added to make it a perfect square. What must be added to a number in order to make it a perfect square. So here again I want to tell you that actually we have not got, the question is definitely not a perfect square. Okay, the question is definitely not a perfect square. So after adding something, it will become a perfect square. So let us see. Let's take 564. What must be added to this in order to make it a perfect square? That is the question. Okay, so again let's do the pairing, and then this is the 2, sorry, this is a 4. Okay, 164. Bring down this 2, it's a 4 and a gap here. What should we put here so that it comes close to this? Okay, so this is 4, and what should we put here? This is, I can take if I take a 2, it's going to be 84, which is very less. So I can take 3, that is 126, again pretty less. Okay, why not try with a 4 to 4, 16, but then 16 and 176 we have exceeded. Okay, so 43 into 3, that is 9, 129. Okay, so I think 44 into 4 didn't fit because it became 176, but 43 into 3 is a 129. So I think this is going to fit. So here there is a 5 and 35. 35 is the remainder. So we already know this isn't a perfect square. So it is quite obvious that we will get a remainder. Okay. Now the question is, okay, here I should write the 3 and here another 3. So the question is, what must be added to make it a perfect square? Means they are asking for the next perfect square after this, the perfect square which comes after 23 square. Okay, 23 square is little less than this. Okay, this is slightly more than 23 square. So let us find 24 square. Okay, 4 was a 16, 1, this is 9, and then this is 48. Okay, 6, 7, 576. If this is a 576, 24 square is a 576, and here we have 564. Okay, now what must be added to this number to get this? I think the answer has already become very clear to you all. That is 576 minus 564, that is a 2 and 1. Okay, so 12 has to be added. 12 has to be added to make it a perfect square. Okay, now here I want to tell you all that, remember, I just did one sum with what must be added to, and then I did one sum with what must be subtracted to. Okay, what must be subtracted from. Now these two types of sums should only be attempted using division method of finding square roots. There were two other sums, which was what must be multiplied to and what must be divided by in order to make a perfect square. Now that was only by prime factorization method. So the two methods are clearly different for the two types of sums. Okay, next question is, find the perimeter of a square. Find the perimeter of a square whose area is 7056 meters square. Okay, find the perimeter of the square whose area is 7056 meters square. Now perimeter is the sum of the boundaries at the side. Now the first thing, remember, in a square, if the sides are a into a, okay, so practically a square is 7056 here. So a is what? A is the square root of 7056. Now let's find the square root of 7056. Okay, let me try out with division method only. 7056. This is pair it and then write 8. 8 is a 64, and then 6, 56, make it 16, and what here I think we can put a I think with a 4, yeah. If we take a 4, 164 into 4, 4 4 is 16, 64, 65, 6, 56, and this is 4. Okay, so the square root of 7056 has come to an 84, means each of these sides is an 84. Each of these sides is an 84. If each of these sides is an 84, how much is the perimeter? Therefore, the perimeter is how much? Perimeter of the square is 84 into 4, right? Because we are adding it 4 times. 4 4s are 16, 1, 3, 36, right? Meter, no meter square this time, it is perimeter, so it is only meters. Okay, so this is the meant by perimeter of a square, and this is how you find, if area is given, how will you find the perimeter? First find the side and then find the perimeter. Okay, now before I end the video, I want to tell you all once again, this is very important, so I feel I should write it down. So here I want to write it down. What must be added and subtracted type by division method, okay, and what must be multiplied with or divided by prime factorization method. Remember this clearly, okay, because I don't want you all to waste time starting the sum with prime factorization when you have this type of a sum. Okay, so that's it for today. I'll stop the video here today, and I'll come up with another video. So square roots is coming in 4 parts. Okay, so we have finished. This is the third part of square root. In the next video, that is part 4, you will see that I shall be doing square root of a decimal number by division method, and few very important types of questions also we shall be taking up. Okay, so till then, keep practicing, and if you have liked the video, do not forget to like, share and subscribe. Thanks all of you. Bye then.